The plastics that are in the landfills, there's no space for them anymore. It turns out that you can't just sweep it under the rug. This little pile of dust is now a giant mountain that you can't ignore. We have to come up with a solution.
We work with polysaccharides. Every organism on Earth has polysaccharides in it. They're renewable, they're all natural and degradable and relatively non-toxic materials. Lots of polysaccharides have potential as plastics to replace the things that come today from fossil fuels.
There's always a give and a take. Natural materials, sometimes they can be a little bit more brittle than maybe petroleum-based. So how do you take something that nature provides, modify it so it's as good as a petroleum-based material, so that you eventually replace these petroleum-based materials with something that is as inexpensive and as good in terms of properties?
Some of the work we've done is to take starch and to modify it with a branch off of the starch that has a lot of affinity for the polylactic acid. And so that stuff that we're making, that we're creating, we're designing, we're synthesizing, can bring those two polymers together. And now the property of that plastic you're going to get from those two polymers is a mathematical average of the properties of the two polymers. That's what you want. You want to be able to mix one that's really stiff with one that's really flexible, right? You want to mix one that has a great ability to absorb impact with one that doesn't. And now you have something that's actually going to work as your water bottle, as your park bench, as your piece of tape, whatever it might be.
We are very fortunate to be at Virginia Tech doing this work. I feel that a lot of the researchers on campus have or share the same passion to improve society through this mission of sustainable biomaterials.